Hi, welcome to this demo of IBM Spectrum Protect and Spectrum Protect Plus's Open Snap Store Manager, also known as O.S.S.M. O.S.S.M allows you to take the Spectrum Protect Plus backups and store them in the Spectrum Protect's container storage pools. This gives those backups the ability to share the storage as well as the deduplication that is built into the Spectrum Protect container storage pools. In this series of videos, James Damgar will be walking you through installing the O.S.S.M package, configuring and backing up virtual machines from Spectrum Protect Plus into Spectrum Protect using O.S.S.M, and then doing a restore from that common data repository, as well as a replication of that backed up data to an additional Spectrum Protect server. This third video will do a test restore of a virtual machine from the Open Snap Store Manager repository, and it will show you how to replicate the data from one Spectrum Protect server to another. So with that, I'm going to go ahead and turn it over to James.
Hello everyone, my name is James Damgar, and today I will be taking you through the steps to actually run replication and restores with OpenSnap Store Manager with IBM Spectrum Protect and Spectrum Protect Plus. First, we can show how to conduct restores with Spectrum Protect Plus from O.S.S.M. So revisiting the system configuration panel under storage in O.S.S.M, we do have two separate O.S.S.M instances that I configured earlier, tapserve02 and tapserve17. One of these is a replication source, and one of these is a replication target O.S.S.M instance. For setting up replication between two instances, you'll need to perform the prerequisite steps that we outlined in our documentation. And the setup is very similar to how you would set up normal storage rule replication between two servers on the Spectrum Protect side. The storage rule itself is actually created by Spectrum Protect Plus when you associate these two servers within this GUI, but you need to do a define server in each direction as well as some other prerequisite setup steps so that those servers can communicate with each other over TLS. Once those prerequisite steps are done and we have the two servers identified, we can go to the server that we intend to be our source server and click on Manage, and we can configure a storage partner, which is the replication target system that we want. So here we've already added tapserve02 as our replication partner. When that server is added, Spectrum Protect Plus will go off and create a replication storage rule for all O.S.S.M related nodes. So to actually run a replication job in the Managed Protection Policy Overview section, we can actually look at our SLA. So in this case, we have this O.S.S.M prod SLA, which ties together our two replication systems. We actually have enabled our replication policy and have chosen our target site as the REPL VM site, which is the site that's containing the tapserve02 system. So to enable replication with an SLA, you'll want to click this checkbox for backup storage replication, and then choose the target site where the target O.S.S.M storage resides, which will need to be different than your source site. To actually run replication, if your schedule is configured to run automatically, backup will run first and then replication will run afterwards. Or you can run a replication manually by going to your associated schedule, clicking on Start. It'll then prompt you if there is both a backup and replication portion of the policy. You'll be able to choose which one you wish to run. So you would just hit Replicate and then click OK. And that would kick off your replication job. I'll actually give this a try here. It'll now appear over here as a running job. So this will show up as a type backup replication job. It'll create the storage rule if it does not already exist between the two Spectrum Protect servers, and then it'll drive the running of that storage rule in the background. So in this case, I had 11 virtual machines configured in the source SLA, and those will be replicated to the target SLA. So I'll let that run in the background as well. So now, as far as conducting a restore goes, from the Jobs and Operations panel, you can click on Create Job, Restore. We'll want to select VMware, and then we'll choose which virtual machine we want to restore. You can do a search here, which will examine your inventory. So I'll pick this virtual machine. You can either choose to do an on-demand restore or a recurring restore that repeats periodically. We'll just do on-demand for now. You can select the time range in which the backup you want to restore from was taken. So this will show you all of the different restore points that are available for this VM, both backup and replication for whichever SLA policies have backed up that VM. So in this case, I'll want to actually do a restore to my replication target server using the replication copy for the backup I took on August 19th. So I'll select that restore point and select the replication target. Click Next. And when you're doing a restore, you can restore to the original ESX host or cluster or an alternative host or cluster. You can customize the IP configuration of the VM. And in terms of how you can conduct restore, you have three options. You can do a production restore, which replaces the original VM in the vCenter catalog and inventory. You can do a clone restore, which is similar to a production restore, but creates a new copy of the VM to your VMware infrastructure. And thirdly, you can do a test restore, which will actually do the restore directly from O.S.S.M storage and run the restore from O.S.S.M storage. So we'll do a test restore for now. Optionally give it a unique name, otherwise it'll append a timestamp onto the VM name it creates, which is fine. Hit Next, and we will hit Submit. So now the restore job will show up shortly as a running job, as an on-demand restore. For the test restore, what Spectrum Protect Plus does is it will share the volume for the virtual machine from the proxy system over to VMware as a NFS version 4 data store and register the virtual machine as a new virtual machine over in VMware. So that's what's occurring now during the first portion of the job. So one of the first things it does is it creates a clone of the snapshot for that restore point as a new volume, in this case volume number 80, assigns that to the proxy system and mounts it as a file system on the proxy, registers that as a NFS version 4 data store to VMware, and is now creating the virtual machine with that custom timestamp name on the end. So now we see our on-demand restore is complete with a green bar. This on-demand restore, since it's a test restore, will stay active within the GUI so long as the active virtual machine resource is present. So if we go over to this active resources tab on virtualized systems, we can actually see that this VM is listed as an active resource. If we go to the VMware vCenter GUI, and I can actually search for the VM, and we see that it's been registered within VMware. So I can click on this VM here. We go to its data store. This is the NFS version 4 data store that's being shared out from the proxy. So we can even take a look at that. We go to the summary page. We can see the server it's being shared from, which is our proxy system in this case. And then it'll actually show you the full path on that proxy system where it's being shared from. And if you were curious, on this particular replication proxy, we can see that this volume is now mounted at that same path that VMware is reporting. And if we do an export fs-v, we can see that it's being shared. And by default, it's going to share the volume to all of the IP addresses that it sees for the various ESX hosts in the cluster that you're restoring to. So we can go back to the VM, and I'll want to edit settings and make sure I connect the network for this VM, since the original VM is powered down, so I can actually take over its IP interface. And I will power on the VM. So once again, this is a test restore, and this VM will be running direct from O.S.S.M storage. So we'll let that come up, take a couple of minutes, and then we'll be able to log into it. The replication job is actually finished. So when a job finishes, it'll appear in the job history tab. Here we have our replication job, which was successful for the 11 VMs. And you'll see a summary of how much data it transferred and how long it took. and its overall job state is completed. The latest version of those VMs have been replicated to our target server. Okay, so now looking back at our instant access test restore VM, it should now be booted. We can actually open the web console, but this system should have a network interface configured, so I can start him up here. And here we have the virtual machine running from O.S.S.M storage live. So in this case, we can come in, we can do things like start up and examine a database. We can do virus scans. We can look at individual files. We can do other types of test operations on this system. When we're done interacting with this VM, you can go to the Jobs and Operations panel, look at your active resources, virtualized systems. You can select this VM, and you're given a few different options here. If you want to keep the VM, you can either move it to production or clone it. And this actually uses VMware Storage vMotion to move the VM from O.S.S.M storage over to VMware Infrastructure Storage. You can replace the original production VM, or you can create this new VM as a clone. Or if you no longer need the VM, you could just choose to clean up. So that's what we'll do here. By hitting cleanup, that'll actually wind down the restore job, deregister the VM, deregister the data store, and unmount and remove the snapshot volume from the proxy. So we see that that's been done. Actually, any of those three options, cleanup, promote, move to production, or move to clone, will result in the restore job completing and the snapshot volume going away on the proxy. Okay, and then from within the Spectrum Protect Operations Center UI, we can actually monitor both our primary and proxy O.S.S.M systems, so the state of the O.S.S.M process. So within the Operations Center, there's now the new O.S.S.M heading, so we can click on that tab. And this will show us our various OpenSnap Store Manager systems that we're monitoring. So what will be listed here are the primary systems. So these are the O.S.S.M instances that are running on these Spectrum Protect servers. So for example, tapserv 17. If we click on this and go to details, within the details page, we'll actually see all the proxies that are associated with this primary instance. So in this case, we have two, and actually these are each associated with a different Spectrum Protect Plus instance. So it is possible with O.S.S.M to have a single Spectrum Protect server that is talking to more than one Spectrum Protect Plus server, since each one of these Spectrum Protect Plus servers use a separate registration key and get a separate node name associated with them and a separate policy domain. All of the data and resources are fenced off from one another. So in this case, we can see that each of the Spectrum Protect Plus instances has a separate proxy that's associated. We can see that they're synchronized and when they've last been synchronized, and that gives us a sense of their health and status. From the keys page, we can see our current set of registration keys. So this first key is a registration key. So if we were going to add a new Spectrum Protect Plus instance talking to the tapserv 17 Spectrum Protect server and O.S.S.M, we would use this registration key. From within the GUI, you can actually generate a new registration key for OpenSnap Store Manager. This is something that can be done from the command line using the configuration wizard as well for O.S.S.M, or it can be done here within the Operations Center. Once a Spectrum Protect Plus server is registered, it then gets a API application key associated with it. So we can see those listed here for our two Spectrum Protect Plus instances and when they were created. Also within this GUI, we can delete or revoke these keys and also copy them for ease of use for pasting within the Spectrum Protect Plus UI. And if I wanted to add a new system for monitoring, I would click on the monitor, and listed here will be the hub server as well as all the spokes that are attached to that hub. And in this case, you would enter in the port number for O.S.S.M that's running on the server system, as well as the operating system username and password that both the Spectrum Protect instance as well as O.S.S.M are running underneath. Okay, and I thank you very much for watching this video and going on this OSSM journey with me. And I invite you to check out the other awesome Spectrum Protect and Spectrum Protect Plus related videos that we have out there on YouTube. Have a good day.